So last but not least is then obviously the function mesh. So we saw in the previous example, it's that this process has to be done to deploy. It has to be done individually, every individual function one at a time. That becomes a bit cumbersome, doesn't scale well as you start adding the number of Pulsar functions used for your solution, right? If you have one or two, it's pretty easy to set that up and running and keep the configs and have a script that starts them up and runs them. When you start to get into 10s and 20s and 30s, then it becomes a little more harder to maintain, particularly if you want to use your Pulsar functions, as we mentioned in the first section, as a change sequence of events, like an ETL pipeline. I want to do function 1 has to run, then function 2, and then function 3. And I want them all to be treated logically. They'll have to work together. It doesn't make sense to have one without the other. And so that's what function mesh was designed to do, to make bundling and grouping of these Pulsar functions much more manageable, treat them as a logical mesh of like an application unto itself as a sequence of smaller Pulsar functions. So conceptually, the definition or the language to use inside of function mesh are streams, functions, and connectors. They each serve a different purpose. Obviously, the stream is your maps back to your topic. It's a append-only sequence of events, of facts. A function is your lightweight event processing that consumes the messages, does some processing on it, and produces to one or more output topics, or actually, output streams. And so it could be a just logic stream mutator from one stream to another. And then obviously the third definition is connectors. It's an event processor that either brings data into a stream or publishes data from a stream into an external system. And there's two types supported in Pulsar functions. They're basically mapped back to the Pulsar IO framework, which are sources and sinks. So basically function mesh will support Pulsar IO connectors that are of type source or sink as well. So what is a function mesh? It is just a collection of function and connectors that are connected by streams that are all orchestrated together. So you can think of it as a large DAG or directed, acyclic graph, although I guess cycles are technically could exist in them, but it doesn't really make that much sense to have a cyclical graph in there. You can think of it as just a mesh of data comes in from this particular source, goes to this input topic or stream. There's a function that processes it, writes it to another stream, another function that consumes it from there, and then eventually writes it to a source and pushes it back out, for example, right? So they all share the same life cycle. They're all managed collectively as one larger unit. You do not have to, if you have 5 functions all that need to be orchestrated together, you don't have to have 5 separate create commands, stop commands, update commands. To do that, you can define them as a single logical unit, and they all either get started together and stop together. And this makes it much easier to manage them. There's all the functions are started when a mesh is created and terminated when it's destroyed. And the functions and connectors in the mesh are auto-scaled to adjust to the workload. So they detect back pressure between the two. So if it's falling behind on an input topic or the stream is getting further behind, we can automatically detect that and scale up those number of instances, assuming that subscription types supports it. If you have an exclusive type, then there's really not much you can do. If you have a shared subscription type, then you can obviously scale up those. And again, logically, you can think of it as a graph, as kind of shown here, right? So you can have one or more input sources coming in, and then those input sources write to a stream, and these functions, you have different functions consuming off of that same input topic, doing different things, doing some enrichment, doing some transformations, things like that, eventually publishing that data back to an output topic, having a sink, so going to Elasticsearch finally. And this is just one way logically to think of it. This is just one example. You can have multiple functions. You don't have to have sources. You don't have to have sinks. You can have all functions. You can have sources and just sinks, whatever you want. Any combination of these are all supported. But it's just basically saying all of these different units, these 5 blue boxes are all separate individual pieces of code, user written functions here for 1, 2, and 3, a Pulsar IO source connector, Pulsar IO sync connector, maybe from Connector Hub, all wired together, all to do one particular piece of logic. Think of it logically breaking it up into individual methods that process the data from the database and enrich it, transform it, put it into Elasticsearch. Under the covers, what function mesh is it's just a Kubernetes operator that enables users to run functions and connectors natively on Kubernetes. So again, it only applies to this feature is only available for the Kubernetes runtime. It's not available for the process runtime, not available for the thread runtime, right? So this is because it relies heavily on Kubernetes scheduling functioning, and make sure that everything's up and running. The serverless framework also, coordinates these different functions and IO connectors together to package and deploy more complex streaming jobs as a single logical unit. So how it works, again, it leverages the Kubernetes APIs, so it can be managed using existing Kubernetes tools. We didn't have to write a separate API for that. So instead of using the Pulsar admin CLI tool to do the function admin things like create the tool or create a function, update a function, delete a function, you can now use the kube control to submit a function mesh CRD manifest, which are just the custom resource definition. So you can define, hey, it's a way Kubernetes defines resources. Those of you not familiar with Kubernetes, I definitely encourage you to do some research on what a CRD is, but it's basically a text file that Kubernetes can process to say, these are my different resources I want to run and execute, and then you can embed functions inside of there. And then that way the kube control looks at it and reads it and says, okay, this is what I have to do. It translates that CRD manifest into the corresponding admin requests as lower level REST APIs we saw in the function workers to create Pulsar functions, to get them scheduled in the Kubernetes runtime and then get executed as well. Again, so if there's any change to the CRD, so you can have an existing you start with the CRD, which we'll see examples here in the next slides. It uses that to create the Kubernetes resources and run the defined functions inside of that, right? So you can sort of internally, this is what it looks like. You're going to have different function YAMLs and source YAMLs and syncs, and your function mesh. All these configurations get processed by the kube control tool. They interact directly with the Kubernetes API. It translates that into different functions, and so the function mesh operator has a corresponding CRD custom resource definition for each one of these there inside your individual mesh. It updates those, so it can say, I want to change this. You do an update, it updates the CRD, and then the CRDs get translated into stateful sets with individual pods for each individual function. So this is just expanding one. There's multiple functions, but inside a pod can be a function, a source, or a sink. Each one is sped up and running independently. They're auto-wired again from the input and output topics for you as well. And then these function runtimes can interact with the Pulsar cluster. So they could run inside the same Kubernetes cluster, typically within the Pulsar namespace as well. So the networking connection is minimal. They go straight, they're within that same subnetwork, so they can connect to one another and access the data. So the function runners can create their consumers to this Pulsar cluster, consumers and producers, and it's all inside that individual pod as well. So it's all runs there, and this is what the function mesh internals look like. So if you want to use function mesh, you think it's the coolest thing. Basically, you still need to package your functions as you did before. So you still have the artifacts, you still create these jar files, Python files, pip files, Go files, whatever you want. You can mix and match them too. There's no reason you can have to have all Python or all Java. You can mix and match them, but then you define your CRD custom resource definitions for functions and connectors and function mesh, and then submit them to the Kubernetes clusters. Using the kube control apply, you just say, hey, this is my CRD for this particular resource there, and then it knows how to read it. The function mesh operator was able to read those CRDs and convert those into the actual REST calls and Pulsar functions to create and define these artifacts as well. Right. So once the Kubernetes receives the CRD, the function mesh operator, there's listening and schedules these individual parts and runs the functions as a stateful set from there. So you can say, this is my function as well, define them all together. So if you want to define them in a single two functions rather than one. So we saw in the previous configuration file, we saw when we're configuring the Pulsar functions, you had one config file per function. Here you can have many, right? So this is just showing you two, but 2 is just an arbitrary number. You can have 5, you can have 10, you can have however many you want, and it's just defined here, right? So there's a special type called a function mesh. When you define your particular CRD, this is your API version, the type, the metadata, any sort of metadata you want to add. That's up to you for tagging, things like that. And then here's the real meat of it. The specification, you can specify as many functions as you want, each with a different name, class name, replicas, as far as instances. And then the configuration under this point is exactly the same as you saw in your config, right? So this is my input topics. Now this is the schema type for this particular input topic. This is the output topic that I want. For Pulsar, this is my Pulsar configuration. This is my jar file. This is where the jar file is located. Similar, you can have another function here, a second one here having its own definitions, replicas, input topics as well, configurations, and so on. And so this is one larger manageable unit. You have to change one or two things, instead of having separate ones managed, you can have it all in a single function, and then you do a CRD kube control deploy, and it just executes, and all of those individual functions defined here in the CRD are inside this definition file here are just spun up and for you automatically. You do a create, they get spun up. You do a delete, they all get spun down simultaneously at the same time. And that's all I have.